In this lesson, we're going to discuss the topic of real numbers. Real numbers constitute the group of irrational numbers and rational numbers. So irrational numbers is a smaller group, but rational numbers has all these other subgroups inside of them that contain even more special and specific types of numbers. So all of these numbers that you see, or all of these words that you see here on the screen, constitute the group of real numbers. So if you're a real number, you are anything that you see on this screen. You can be crazy, or you can make sense, but you're in one of these groups. So if you're a real number, you're either irrational or you're rational. You cannot be both. It's kind of like being an earthling. If you're an earthling, that makes sense. And if you're a Martian, that's crazy. But you can't be both. So the group of real numbers, let's start with the irrationals. The irrationals are a set of any number that cannot be expressed as a ratio. You cannot write it in fraction form. And those numbers, when written in decimal form, would go on forever. That's called non-terminating. And they never repeat, so without repeating the same pattern. So here's three quick examples. You can have the symbol for pi. You could have the mathematical equivalent of pi, which actually can't even be written out because it goes on forever. And that's what those three dots represent. And you could have something like the square root of 2. Now, you might not know if it's irrational, and so you have to kind of think about what it's equivalent to. And that can be hard if you're not familiar with your perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4. Because if you look at your calculator and you actually type in the square root of 2, sometimes students will say to me, well, it ends. It's 1.414213,562. It actually doesn't end there. The reason it ends there is because my calculator ran out of spaces. So you kind of have to be familiar with the radical symbols and whether or not that number can be written in equivalent terminating form. So here are three quick examples. Pretty much anything that you've memorized as a perfect square is not irrational. So the square root of 2 is irrational, but let's say we had the square root of 16. That's not irrational. Remember, an irrational number cannot be expressed as a fraction, as a ratio. So if you can express a number as a ratio or as a fraction, it is always rational, no matter how crazy the number even is. 7 divided by 9 or 7 divided by 19 even. 7 divided by 19 seems like it's going to be pretty scary. Let's see what that looks like on my calculator here. 7 divided by 19. Looks like it doesn't have a pattern. 3, 6, 8, 4, 2, 1, 0, 5, 2, 6. But like I said before, my calculator ran out of spaces. So it actually goes on more than this. My calculator just doesn't have the capacity to show me. So I'm going to show you the output on a more high precision calculator. So I Googled a calculator, and this is what I saw when I entered 7 divided by 19. I saw 0.36842105263157897, and then I saw it 3684, and it keeps on going, keeps on going, but there it is. That is the beginning of the pattern. So it was hard to see. I changed that to a 19, right? It's hard to see it, but all these characters are the pattern. And depending on how many characters your calculator can show, you wouldn't know that there actually was a pattern there. But you would know because you know that any number written as a fraction is rational. So just the fact that I have a fraction here means that it belongs to the group of rational numbers. Okay, so let's recap those three vocabulary words that we learned already. So the set of all numbers that contains rational and irrational, those are called real numbers. Now within those group of real numbers, you have two categories. You have to belong to one or the other. You're either irrational, which means that you never terminate, you never end, and you have no repetition. like the square root of 3, or pi, or the square root of 5, or the square root of 41. Or you could belong to the rational group, which is anything that can be written in fraction form, anything that can be rewritten as a over b. These quantify also as, if it's in decimal form, it actually terminates or ends, or it has a pattern that repeats. So here are some examples of rational numbers. 5/7, 3, -1, 25ths, the square root of 16, 0, 2/3, etc. There are lots and lots of rational. All right, so let's talk about how we break down this group of rational numbers. So if you are a member of the rational numbers group, it's kind of like you live on Earth. There's lots of places you can live, but if you live in the United States, that would be a smaller group of people, right? That would be like a smaller group of numbers. So the integers are a smaller group of rationals. So there's lots of numbers, right? Lots of human beings on planet Earth, but not all of them live on the United States. So there are lots of rational numbers, but not all of them are integers. So like 1/2 is a rational number, 0.5 is a rational number, 3 is a rational number, -3 is a rational number, but not all of these four are integers. Integers are numbers that have no decimals in them with the exception of a 0.0. So if I have 1/2, which is equivalent to 0.5, that is a decimal other than 0.0. So these two numbers here would not be invited to the integer party because they're decimal equivalents of 0.5. But 3, which is 3.0, and -3, which is -3.0, they're allowed to be a part of this group because they have no decimals other than 0.0. So we have the number 3 here, and we have the number -3 here, and now we're kind of trying to figure out which one of these is more special than the other. Which one of these two values is going to be invited to the whole number party, right? So your rational means you live on Earth. If you're an integer, it's kind of like you live in the US. And if we want to get even more specific than that, we'd say we lived in New York, right? So if you want to get even more specific than being an integer, you would say you were a whole number. And the only numbers invited to this party are numbers with no negative signs. So -3 would not be allowed to come down into the whole number group, but +3 can. So some examples of whole numbers would be 7, 9, 3, 0. Those are all whole numbers because they have no negative signs. So everybody can come to the rational party, but only the 0.0s can come to the integer party. And only the positives can come to the whole numbers. So in order to be in the whole number category, you have to have all of these requirements to get in. You have to be able to be written as a fraction. If you want to come into the integer group, you cannot have a decimal other than 0.0. And if you want to come to the whole number group, you cannot have a negative sign. Now, if you want to get to the most specific group of all of the whole numbers in the whole group, all of them are invited to the natural numbers party except the number 0. So -1 is not invited into the whole group, but +1 is. +1 is also a natural number. 0 is a whole number, but it's not part of the natural group. So here are your specifics. Every fraction is rational. Any fraction with a decimal other than 0.0 is an integer, right? The ones with the 0.0s are integers. All of those groups, which have no negative signs, are also in the whole number group. And everything except 0 that's a whole number can come down into this natural group. Right? So rational numbers are like living on Earth. Integers are like living in the US. Whole numbers is like living in New York. And natural numbers is like living in Westchester. So as you move down the group, you get much more specific. Much more specific. So let's take a look here. I have a couple of examples. If you want to give this a try, pause the video, make 2 circles, and put the numbers in the right place. Alright, so here we go. I've got a negative number, but it is a decimal, and it doesn't go on forever, and it doesn't repeat. It's -2 and 1300ths. That's rational. Now I have 4/9. I don't know what it's equivalent to, but it doesn't matter because it's a ratio, so it's rational. Let's see, I have this decimal 0.78 with a repeating bar over it. So it does go on forever, but I know what's happening next, and it's the same as what happened before. 0.78787878, so that's rational. How about this one here? It goes on forever and ever and ever, and it looks like it has a pattern, 2, 4, 2, 4, 4, 2, 4, 4, 4, 2, 4, 4, 4, right? I think I know what's coming next, but is it the same as what came before? And the answer is no. It's not the same pattern each time. So that's crazy irrational. Pi plus 3. Pi is irrational. Therefore, if I add something to that, it's still irrational. It's just 3 more than that. 13/17 is a pretty crazy decimal, but I know that it's a ratio. It's a fraction, so it's rational. This one here has the 3 dots that mean it goes on forever, and there's no pattern here in what they've shown. Therefore, we're going to call that irrational. The absolute value of -3, which is +3, can be rewritten as 3/1, so that's a rational number. Here are some examples of something else you might be asked to do, which is name all the sets of numbers to which a number belongs. So let's see, don't forget we have the irrationals and we have the rationals. And if you are in the rational group, you might be an integer, you might be a whole number, and you might be a natural number. Remember, all fractions are rational, all decimals that end or that have a repeating pattern are rational. But in order to also be a part of these other groups, you have to have those special character traits. So to be a part of the integer, you have to be a 0.0 number. If you are invited into the integer group, you might be a whole number. But you cannot be a whole number unless you are an integer. So let's see what we've got here. We've got -47. -47 is definitely -47.0. It's -47/1. So I've got fraction, I've got decimal form. So I know it's rational. So I'm going to say that this one here is a rational number. So I'm going to put rational. And now I'm going to go down my list. Is it an integer? Yes, because it's a 0.0. And I'm going to go down again. Is it a whole number? Meaning it has no negative sign. Unfortunately, it has a negative sign. So I've got to stop here at the integer level. I cannot check anything else. As soon as you get a no, you are nothing below that. The only other word I could add here is that that actually is a real number. But every single number on this page is going to be a real number. Why don't you give the rest of these a try and pause the video, and then I'll put up the solutions. So here are the solutions in any order. The vocabulary can be in any order, but it will contain all of the vocabulary that pertains to each value. So you'll notice with question number 3, I started off with a negative sign in the actual question, but because the absolute value of -9 is actually equivalent to +9, then it would be an integer because it's equal to a positive value. And it is positive, therefore it's also a whole, right? And because it's not a 0, it's also natural. Let's look at a couple more practice questions. So now we're going to use this diagram to help us sort the numbers again. So here are a couple of questions. They're labeled A, B, C, D, E, F, G. So if you want to use the letters, you can put them in the appropriate circle by using this letter here. So I'll do one for you. I'll do C. Okay. So C, which is the number 8, can be written as 8/1. So that means it is part of the rational group. So now I'm going to take this letter C and I'm going to see how far I can move it down the chart. So it is a fraction. If I write it in decimal form, it is a 0.0, 8.1. It is a positive 8, so I can move it down to whole, and it's not a 0. So it belongs in the natural circle. So if I asked you, what are the vocabulary words for the number 8, you would say, it's rational, comma, integer, comma, whole, comma, natural. So go ahead and pause the video and give these a try. Here are the solutions to these questions. And that concludes our video on real numbers. Hope that helps.